Hello everyone. Am I audible? Good evening everyone. Please quickly tell me am I audible or not? Hello everyone. Guys, please quickly tell me am I audible or not? Excuse me. Great, I am audible. So we will be starting the session in 2 to 3 minutes. So till then, if you guys have any kind of doubt regarding yesterday's session, you guys can ask me or regarding anything. If you guys have any kind of doubt regarding yesterday's session or anything, you guys can ask me. Okay. We will be starting in 2 to 3 minutes. Good evening, everyone. Good evening. What will this bootcamp benefit in our career? So, if you guys are interested in the field of data science and like if you really want to explore, so this will be a very great opportunity because I'm starting everything from the scratch. So, like if you guys are really interested in this field, so this will be a very beneficial bootcamp for all of you. Yes, within 2 to 3 minutes, I will be starting with the recap first of all, and after the recap, we will be starting with the today's session. Okay, like today's topics and all. So we can find the good data set for practice. So Kaggle is the best platform to find every kind of data set. Okay, whenever you are doing some production work or something, so the data set you have to extract from like real time data. But for practice purpose only, Kaggle is the best place from where you can extract the data set. Okay. The certificates will be distributed after the all the 5 days of the session. Okay. Kaggle we are going to use just for the data sets. Okay. So we are not going to use Kaggle for the coding part. We are going to do all the codes on Google Colab. And when we have to deploy our codes, like in most probably in day 4, I think so. Whenever we are going to deploy our code, day 4 or day 5, I think, then we are going to use VS Code. If you have missed 1 or 2 day class, don't worry, just fill out the other two like other days, okay? The attendance for the other days. Don't worry. Okay, sorry. So let's quickly begin with the session now. I hope my screen is visible, guys. Am I right? My screen is visible, right? Great, my screen is visible. Yes, I am also doing it in Collab, so everyone can do it in Collab. So let's firstly start with the basics of machine learning that we did in yesterday's class. Okay. So the first thing we have seen is like the basics of ML. So we have two fields. First is AI, the second is ML. We also have DL, but we are going to talk about DL in the future. Okay. So we have two fields. First one is AI, that is artificial intelligence. Okay. And the second one is machine learning. From the name itself of the machine learning, you can say that when machine is learning something. Sir, machine is learning from what? Machine is learning from data that we are going to give to the machine. Okay. Okay, sir. So in total, we have three fields. The first one is artificial intelligence. Then under artificial intelligence, we can say that we have a field of machine learning. So we can say that machine learning is a subfield of artificial intelligence. Then deep learning is a subfield of machine learning, which deals with neural networks. So what is neural networks or what is deep learning? Deep learning is nothing but a mimic of human brain. Okay. And under, if you guys want to know, under deep learning, there is a field known as generative AI. Okay, so if we are going to talk about generative AI, so generative AI is a field which is a subfield of deep learning, we can say. And generative AI, agentic AI, and all totally deals with the types of LLMs and what kind of task we can perform with the help of LLMs. Now, sir, what is LLMs? So, LLM is nothing but you must have heard of ChatGPT, right? So, LLM is nothing but large language model. Then the next thing is what is data. So, data can be anything through which we can gain some kind of valuable information. Like right now, I am talking to you guys, so my voice is also data for you. Right now, I am sharing my screen, so the screen or whatever I am writing on the screen is also some kind of data for you. It is not like data is only the numerical values in some particular columns and all. Data can be anything. Data can be anything through which we can gain some valuable information. Okay, I hope this is clear. Then the next thing we have studied was the machine learning. What is machine learning? So machine learning is nothing but the field of AI used to train our system on some data. Okay, so machine learning is a field of AI, a subfield of AI, and it is basically used to train our system on some data so that we can get a specific type of output. Then there are three types of machine learning we have seen. The first one is supervised learning, the second one is unsupervised, and the third one is reinforcement. Okay, in supervised learning, the machine trains on label data. As you can see over here, the machine trains on label data. Now, sir, what is label data? As you can see, this is label data. Sir, what is label data now? So when I am giving, like, this is my machine, right? This whole is my machine, right? So when I am giving some kind of data with some labels over here, like over here I have given the label as apple, over here I have given the label as banana. So whenever I am giving my data with some app with some labels, I am going to call it my label data. So my machine over here is training on the label data, and after that I am getting some kind of output over here. So when my machine trains on label data, I call it supervised learning. In unsupervised learning, my machine trains on unlabeled data. As you can see, I have not given any kind of label over here. What my machine is doing, based on some kind of features, like the features we can say features like color, we can say texture, or we can say shape, and many more. Okay, based on some features, what my machine is doing, my machine is segregating, is splitting. Okay, my machine is segregating or splitting my data set into two or more categories. I hope this is clear now. Okay, so this is my unsupervised learning. Then we have reinforcement learning, which basically works on four things. The first one is environment, the second one is agent, the third one is action, and the fourth one is reward. Now, sir, what are these four things? So, firstly, the environment. Firstly, the environment. Environment is nothing but the area we are focused on. Okay, the agent is nothing but the, we can say, like have you seen those car races, like in which the car is moving on itself, like based on the road or the track? Like the biggest example of reinforcement is self-driving cars, I know that. But have you seen those car races in which the track is given and the you just put the car and the car goes on itself? So agent is the, we can say, the thing that is doing some kind of work. Okay. Like I have taken the example of a dog in a park, right? So in that example, my dog is my agent. Or in the case of self-driving cars, the car is my agent. Now action. Action is like the task my agent is performing. Okay. Action is nothing but the task my agent is performing. And then the reward is nothing but a small kind of treat or some, we can say, hypothetical points or anything. Suppose I have created an hypothetical point system that whenever my model is going to give a good answer or a correct answer, I am going to give some kind of 2 points or 3 points based on how good the answer my model has given. Okay, so this is a kind of hypothetical point system, or we can say a hypothetical reward system. I have made some kind of this system. Whenever my model is going to predict a correct output, I am going to give him, my model, some kind of rewards, say 2 points or 3 points. So based on that reward, to maximize that reward, what my model is going to do, it is going to predict more and more correct results. Okay, I hope this reinforcement learning part is clear now. Then supervised learning is further divided into two parts. The first one is classification and the second one is regression. Okay. In classification, we have to predict some classes. Okay. Like male or female over here, like true or false, like apple or banana. When we have some particular classes, we are going to use classification. And when we have to predict a continuous value, we are going to use regression. So, sir, what are continuous values? Continuous values are like when we have to predict some kind of house price or age or salary that we don't have any kind of classes, because house price can be any value or age can be any value, right? So these are known as continuous values. And then we have seen the algorithms of supervised learning, and we have seen the imputation part as well, like how can we deal with the missing data part. We have two options. First one is imputation and the second one is dropping. In imputation, what we do, we change the null value with the mean, median or mode of our data. And in the case of dropping, we just simply delete the complete row. Okay, I hope this much is clear now. If everything is clear, write clear in the chat quickly, guys. If everything is clear, write clear in the chat quickly, guys, so that we can start with day 2. Great, great, great. Now in today's session, the goal is to like understand what are the pre-processing steps for a dataset. Okay, like how can we do the pre-processing. Okay, so in today's session, our main focus is going to be how to pre-process our dataset. Okay, so in this topic, we have to cover like 4 to 5 subtopics. Okay, the first one is how to handle missing values. Okay, like this is also divided into two parts, that is dropping, and the second one is imputation. So this part I have covered already. I will also show you the practical once again. I have also shown you the practical before as well in yesterday's session, but I will again show you the practical. The second part is like data standardization. Okay, the second part is data standardization. The third part is label encoding. The fourth part is handling the imbalanced dataset. Handling imbalanced dataset, and like these are the, like we can say, 4 to 5 most important subtopics under the pre-processing part of dataset that we have to cover today. Okay, then after all of these 4 steps, our next step is to, like we can say, um split our dataset, split into x and y. Then we, after splitting our dataset, then we split it into training part and testing part. So all of these topics, like splitting into x and y, splitting into training, testing, and at the end training our model, all these two parts and all the training part we are going to cover in tomorrow's session. Okay, today's goal is to cover all the pre-processing parts. So we have already covered the dropping and imputation part. I have shown you the practical and the theory as well. Okay, so let's quickly start with data standardization part. I hope this much is clear, right? I hope this much is clear, right, guys? If everything is clear till now, write clear in the chat. Yes, great. So let's quickly start with data standardization. So first of all, what is data standardization? The very first thing, what is data standardization? So the process of standardizing a data, okay, to a common format or a common range, we can say. Suppose, okay, let's take an example. Suppose I have a data set over here, okay. My data set, I have say 4 to 5 columns, okay. Suppose one column is of the age column, okay. So age can be anything between, let's say, 18 to let's say 100, okay. So the age column is between 18 to 100, and let's say the next column, suppose this column over here is the salary column, okay. So the salary can be, let's say, 10,000 as well. The salary can be 50,000 as well. The salary can be, let's say 90,000 as well. So as you can see, the two columns that I have in my data standardize in my data set, one column ranges from 18 to 100, the other column, let's say, ranges from 10k to, let's say 10 lakh, okay. So can you guys see the difference? So can you guys see some kind of difference, that sir, some of the columns are between 18 to 100 and some of the columns are between like 10,000 to 10 lakh. So the data is very much, you can say, it is not a good data set, because all the values are like between, some are 18 to 100, some are between 10,000 to 10 lakh and all, okay. So what I can do, I can bring all these values to a specific or a common range, okay. What I can do, I can bring all these values to a common range. And how can I do that? I can do this by performing data standardization. So basic definition for data standardization is, basic definition is the process of standardizing the data, the process of standardizing the data to a common format or common range. I hope this is now clear. Yes, see that these are two different columns, right? Whenever we are going to train our data set now, so my model is going to train, like, some columns are between 18 to 100, some are between 10,000 to 10 lakh. So it is a very varying data set, we can say, okay. So it is a very very good practice to standardize our data set, so that all the values comes under 0 to 1, okay. So that we get all the values between 0 to 1. I hope this is clear now, okay. Or we can say that the process of standardizing the data to a common format or common range is like data standardization. And we can say that when we make the mean deviation, the standard deviation, sorry, not mean, when we make the standard deviation of our data set equal to 1, we call it data standardization, okay. So when we are going to bring our dataset in a common format or a common range, what are we doing? We are bringing the standard deviation. We are bringing the standard deviation of our dataset is equal to 1, closer to 1, we can say, not equal to, exactly equal to, but closer to 1. I hope this is clear now. So let's quickly start with the practical as well of data standardization. So I will quickly open my collab notebook over here. And I will quickly open a new notebook. Okay. After opening the notebook, I am going to connect my notebook from the top right corner, if you can see. Okay. I am going to quickly connect my notebook now. Attendance will be taken at the end of the session. So please right now focus on the session only. The attendance link I will share at the end of the session. So I don't know why it's not connecting. Yes, it's connected now. So the very first thing in Python, always remember that the very first thing we have to do is to import all the necessary libraries that are required to do anything. Okay. Suppose you are going to like just making a smaller project, or you are going to make a great or big project. Okay. The very first thing that you guys have to do is import all the necessary libraries. So I am going to import. The first thing I'm going to import is import. I'm going to import numpy. Now what is numpy? So numpy is a library. um what is numpy? Numpy is a library which is used to deal with numbers, and okay, like which is used to play with numbers, we can say. Okay. Numpy is a library which is used to play with numbers. From the name itself you can also say that. Okay, the name is also made from numbers plus Python makes numpy. Okay. So NumPy is just a library which is used to play with numbers, and all the like main features of NumPy that we are going to use, I am going to tell each and every function and all. Okay. I'm going to import NumPy as NP. So now what is this as NP? So whenever I am going to use NP, okay, so whenever I'm going to use NP, I am going to use NumPy. I'm also going to import pandas as PD. Now, sir, what is pandas? Pandas is a library. Pandas is also a Python library which is used to handle the datasets. Okay. So what I am going to do, I am going to quickly go to Kaggle. Okay. Kaggle is a very good platform for beginners or intermediates, or for even advanced level of AIML engineers and all, to like get the dataset and train your models. Okay. So you just have to go to Kaggle. You have to log in. I have already logged in Kaggle. Okay. And you have to come to this dataset section, and you can search for any kind of dataset now. Okay. Let's say I am going to search for um let's say I'm going to search for iris dataset. Okay. Iris dataset is also a very famous dataset. So iris dataset, I'm going to download this dataset. So as you can see, this dataset is downloaded over here. Now I can simply import my dataset over here. So it's under downloads, iris.csv. Okay. So just give me a second. The dataset is not imported. I'm going to import it again. Iris.csv. Open. I don't know what the problem is. Yes, Iris dataset is a very, very basic level of dataset, so you don't have to worry. Hmm, Open. I don't know why it's not taking the dataset. Maybe it's hang or something. So I'm going to quickly run this first cell first of all, okay? So it's not taking the dataset actually. So what I can do, I can show you a previous code, okay? I don't know why it's not taking the dataset, so that like if it's taking the dataset, I'm going to show you the live code, but okay, let's continue with the previous code, okay? So data standardization. Yes, data standardization. Okay, I am going to just try once again. I don't know why it's not taking the dataset. Okay, leave it. So what we have done over here. Okay, yes, I can also use the pre-installed datasets as well. From sklearn. Okay, so the one thing, sklearn is the library that is used. sklearn is the one library that we are going to use for machine learning, okay? And for deep learning we are going to use the library TensorFlow. So just remember this, sklearn is used for machine learning and TensorFlow is used for deep learning. Many students have confusion that sir, where I don't remember where to use sklearn or where to use TensorFlow and all. So remember one thing, we are going to use sklearn for machine learning and we are going to use TensorFlow for deep learning, okay? So I'm going to import from sklearn.datasets. I'm going to import, because I have to import a data set, right? So I am going to sklearn.datasets. I'm going to import load iris. Okay, so load iris nothing but the same data set that I have downloaded from Kaggle as well, okay? So sklearn by default provides us with some, we can say 10, I think the 10 or 12 data sets, okay? So we can use that data sets to train our model or for, we can say, practice. Great. So the next thing we have to use is from sklearn dot pre-processing. So why pre-processing? Because data standardization is a part of pre-processing technique, right? So we are going to import data standardization from sklearn dot pre-processing. I'm going to import standard scaler. So now what is a standard scaler? Standard scaler is nothing but it is used to standardize the dataset, okay? I'm going to run this now. Now what I can do, I can simply write dataset is equal to I can say load underscore. So all of these datasets are the datasets that are provided by sklearn itself, okay? So these are all the default datasets that are provided by sklearn itself, and we are going to use the dataset load underscore iris, okay? I'm going to write dataset is equal to load underscore iris. No, this dataset is not for the project. You can choose any of the dataset, okay? I am just going to take this dataset as my practice dataset. You guys can choose any of the project, okay? Any of the dataset right now. sklearn is nothing but standard scaler is a part of pre-processing technique, like in which we are going to in which we are going to like uh, standardizing the data and bringing all the range, like bringing to a common range. So it is a part of pre-processing, right? So we are importing the standard scalar over here from sklearn.preprocessing. I hope this is clear. Now if I print my data set, you can see the data set is over here. So this data right over here, this data column is nothing but my data. Okay. This target is nothing but my target column. So what do you mean by target column? Target column is like the column we are going to predict, or we can also say the output column. We have understood in the yesterday session, right, that in classification problems we have a data set and we have to predict some kind of output within like some kind of category or some kind of output, right? Like the fruit is an apple or a banana, or the gender is male or female. So we have to predict some kind of output. So this is nothing but my output column. And as you can see, we have three categories. First one is 0, the second one is 1, and the third one is 2. So we have three categories in our output column. That means it is our classification problem. I hope this is clear now. So what I'm going to write, I'm just going to write df is equal to pd dot data frame. So now what is this data frame? So data frame is a function of pandas. As you can see, I have used pd, right? And over here I have called import pandas as pd. So I have just imported pandas. I've used a function of pandas that is known as data frame, which is used to create like visually appealing data sets, we can say. Okay. So I'm going to write pd dot data frame, and in the bracket I'm going to write dataset dot data. So what is dataset dot data? As you can see, all of this data, all of this data over here lies under the data column, right? So I am going to write dataset dot data over here, comma, and the second thing I am going to write is columns equal to dataset dot feature names. So now what is this feature names? So just give me a second. Yes, as you can see over here, we have also a key with the name feature names, which denotes all the column names. I'm just going to first execute this and then I will show you. So as you can see, I have now column names as sepal length, sepal width, petal length, and petal width. So these column names are nothing but the feature names. Okay, these column names are nothing but the feature names given over here. And we have all of this input data as well, which we have imported with the help of dataset.data. I hope this is clear now. Yes, the lectures are uploaded on YouTube, so you guys can go and watch the lecture anytime you want. I hope this much is clear, right? If everything is clear, write clear in the chat quickly, guys. If everything is clear, write clear in the chat quickly, guys. I can also write df dot head. Okay, sorry, not over here. I can also write df dot head. So head is a function which is used to give me top 5 rows of a data set. The code is when you are going to practice it by yourself, you will understand things more clearly. Okay, so right now I know all of the code and everything is not that much clear, but when you are going to practice by yourself, everything will be much more clearer. So with the help of dot head function, what I am doing, I am printing the top 5 rows of my data set. I hope this is clear now. Now the next thing I can do, Now the next thing that we can do, we can we always have to split our dataset into X and Y. Okay, in which we have in X we have all the input values, and in Y we always have the output value that we have to predict. Okay, so in X we have all the input values, that is in normal DF, and in Y we have all the output values, or we can say dataset dot target. Okay, so we have all the output values over here. Now if I print X, you can see I have the normal dataset over here, and if I print Y, you can see all the output values over here. I hope this much is clear now. I hope this much is clear now. Is everything clear, guys? Quickly tell me in the chat. Data frame is nothing but it is used to we can say create our dataset in this visually appealing format, or we can say into columns and rows and everything, so that we can further do all the necessary steps like pre-processing, training and everything. Yes, target is also mentioned in the dataset. You can see over here the target is also mentioned in the dataset. So let's move forward now. So we have splitted our dataset into X and Y, right? Now what I can do, I will first find out the standard deviation of my dataset by simply writing x dot std. Okay, std stands for standard deviation. Okay, stands for standard deviation. And as you can see, the standard deviation is not like, it is very much closer to 1, which is a very good thing, but it is not exactly very much closer to 1. So what I can do, I will apply standard scalar. So the very first thing, I have to call my standard scalar. Okay, I have defined my standard scalar as scalar is equal to standard scalar. Okay, so I have, first of all, the very first thing I have done, I have defined my standard scalar as scalar. I am going to run this cell now. So the next thing what we are going to do, we are going to simply write scalar dot fit. Okay, scalar dot fit, and I will write x over here, and I'm also going to assign some value. Let's say x is equal to, or let's say scaled x is equal to scalar dot fit. Now if I just try to print scaled x, okay, just a second. Scalar is equal to standard scalar, scaled x is equal to scalar dot fit x. Okay, I will just simply print this. Yes. So as you can see, I have completely applied the standardization or standard scalar to my data set. Okay. Now what I can do, I can there are two functions in every pre-processing step. We have two functions. Okay. The first one is dot fit. The first one is dot fit, and the second one is dot transform. Okay, so dot fit is used to fit our data set into that particular range. Fit our data set into a particular range. Okay, and dot transform is used to transform our data set into that particular range. Okay, I hope this is making sense a little bit. So what I'm going to do, and instead of like doing these steps separately, like dot fit separately and dot transform separately, I can also use this as a single step using dot fit underscore transform. Okay, and if I now print the dataset, you guys can see I have all the values in such a way that I have all the values in such a way. I will just save it again. Okay, I'm saying, let's say x is equal to scalar dot fit underscore transform x. Okay, or let's say scaled x. Okay, scaled x. Now if I will just print scaled x, and as you can see I have all the values in such a way that if I try to print the standard deviation, I have all the values in such a way that if I try to print the standard deviation, I will get the standard deviation as 1 for all the columns. So, and this is the same thing that I told you guys, that in data standardization bring we always try to bring the standard deviation of our data set equal to 1, which means all my data set is now within the same range. Okay, we have the common range for our data set now. I hope this is clear now. I hope this is clear now. The next thing we have to study is label encoding. The next thing we have to study is label encoding. Sir, what is label encoding now? Suppose in my data set, suppose I have a data set and one of the column in the data set is like, suppose let's say city column. Okay, and the values are like Delhi. Let's say the values like Mumbai. Let's say the values like Rajasthan. Okay, let's say the values like any value. Okay, this is a state column, sorry, not city. So we have a column with the name states, and we have multiple values like Delhi, Mumbai, Rajasthan, and many more. So whenever I'm going to train my model does not train. Whenever I'm going to train my model does not train on we can say strings or characters or anything. So what I am going to do, I am going to assign a specific number, let's say 1, to this Delhi word. I am going to assign another number, let's say 2, to this Mumbai word. I am going to assign a specific number, let's say 3, to this Rajasthan word. Or let's say I have a data set. Let's say I have a data set and one of the column is gender. So we will have male and we will have female, right? So let's say now my model is not going to train on this male word or female word. So what I can do, I can simply I can simply apply I can simply write male as 01 and female as 02. I can simply give the values like 1 and 2 to this male word and this female word. So this is nothing but I am applying this with the help of label encoder. Okay, I am applying this with the help of label encoder. So label encoder is also part of pre-processing technique. So what I am going to do, I am going to simply write from sklearn dot pre-processing import label encoder, as you can see. Okay, now I'm going to run this again, and in the similar way that I have called the standard scalar. Okay, I have defined the standard scalar, right? Over here, yes, I have defined the standard scalar as scalar is equal to standard scalar, right? I in the same way I am going to define my label encoder as well, like encoder is equal to label encoder, and I will run this cell. Now in the same way, okay, I am going to perform this label encoding on y, because y, what is y? Y is nothing but my output data set. Okay, not, sorry, not y. So actually don't have any categorical column in my datasets, or we can say any string based column or anything. I have only the numerical columns. So what you guys can do, just go to Kaggle, find out any dataset or this dataset only, because as you can see, the species is a categorical column over here with the word setosa or versicolor or the name Virginica. Okay, so the species column is a categorical column. So what you guys can do, you can just simply download this dataset, upload this dataset over here, and you can use this dataset. Sir, how can we apply encoder? You just have to simply write, like you have used fit underscore transform in the case of standard scalar, right? In the same way, you have to write encoded x. Okay, let's say I'm using the word encoded x is equal to encoder dot fit encoder dot fit underscore transform. Okay, this is the same step with the fit underscore transform that I have used for standard scalar as well. Okay, I have to just now give not the exact table, I have to give the column name now. Okay, I have to give the column name now. And how can I give the column name? I will just mention, let's say if I'm using the iris dataset only, I'm going to mention, let's say df dot df of species. Like these are all the column names, right? I can simply mention any of the column name, but as you can see in this dataset, I have my category column in the species column, right? In the species column. So what I will write? I will write species, but you can mention any column over here. And after running this cell will not run for my data set right now, because I don't have any species column and my column is already a numerical data set. But if you have a data set like a data set like this, in which we have versicolor, we have setos and everything categorical columns, so we can easily convert these categorical columns into 0, 1 or 2 by this single step. Okay, by this single step, I can simply convert these categorical columns into numerical values. I hope this is clear. I hope this is clear. And this cell will currently give me an error because I don't have any, like you can see the error as well. The error is species. So what is this error? I don't have any column with the name species right now. Okay, so that is why this error is coming. But if I have a name, if I have a data set in which I have some species column or any column with the categorical value, I can simply replace this column or from that particular column, and I will get a data set with encoded values. I hope this much is clear. If everything is clear, write clear in the chat quickly, guys. If everything is clear, write clear in the chat quickly, guys. So now what I want you guys to implement this on your system. Okay, what you can do, you can simply, I've shown you all these steps. Just go to this iris dataset. Okay, download this dataset, upload this dataset over here. Then what's the next step you can do? You have to simply write, to get the dataset, you have to write let's say df or dataset is equal to pd dot read underscore csv, and within this you have to mention the path of the data set. Okay, if you will just click on these three dots, you have an option of copy path. Okay, so you just have to copy the path of that data set. I'm just copying some random path. You have to copy that path of that data set, and you have to print that path over here. Okay, in this read CSV part. So why this read CSV? Because as you can see, the data set I have downloaded over here, the data set I have downloaded over here is in the format of just give me a second. Yes, is in the format of .csv, right? So to read CSV file, this dataset is in the form of .csv. If I'll just simply show you the dataset as well. Sorry, this dataset is in the form of .csv. So what I have to do, I have to use some function with the name .read CSV to read my dataset, to get my dataset. I hope this is clear. I hope this is clear. If you have any doubt, you can ask in the chat. Else, please write clear in the chat. How to decode it? But great question. So, okay, this is giving error because I haven't mentioned any path. Okay, so this error is common. Okay, so suppose you have converted male into 0 1. Okay, male into 1 and female into 2. Now, sir, what if I want, sir, what if I want this to convert back into female and this to convert back into male? Sir, how can I do that? So similarly, we have a function like fit underscore transform, right? We have used fit underscore transform to convert it into numerical part, right? So we have a function named as dot inverse transform. We have a function dot inverse transform which is used to convert these values into the original values. 0 1 I have given to male, right? So I will simply write male, and I will simply write 02 will be given to female. So this is how we can convert the values back again with the help of dot inverse underscore transform. I hope this much is clear now. So we have studied, so till now we have studied how can we handle missing values using dropping and imputation. This we have covered in the last lecture. We have in today's lecture we have done the data standardization, and we have also done the label encoding. Now, sir, what is this? And these two topics we are going to cover in tomorrow's lecture. Okay. Now, sir, what is this handling imbalanced data set? Suppose I have a data set. Suppose I have a data set in which I have to predict, let's say I have to predict whether the person have some heart disease or not. Okay. I have to predict whether the person have some kind of heart disease or not. So this is a type of classification problem, right? This is a type of classification problem because we have to predict whether the person have some kind of heart disease or not. So this is a classification problem. So what I can do, and let's say I have 10,000 rows. I have 10,000 rows in which let's say 9,000 rows consist of the person have some heart disease. Okay, the person have some heart disease, and 1,000 rows consist of the person does not have some kind of heart disease. Okay, so suppose I have a data set in which one of the column, in which like a classification data set in which I am predicting whether the person have some kind of heart disease or not. If you yes, so if you have downloaded some file and it is coming as a zip file, what you can do, you can just simply unzip that file. Okay, and you will have that CSV dataset and you can use that. Yes, suppose we have 10,000 rows over here, and among those 10,000 rows I have 9,000 rows as the person have heart disease, and 1,000 rows as the person does not have heart disease. Okay, So can you see this is some kind of imbalanced data set or something? Can you see this is some kind of imbalanced data set or something? So what I can do, like it is not a good practice to balance out the data set and all, because it leads to some kind of biasing and all. I will explain those concepts later on. But what I can do to balance this data set, I can take 1,000 data points. I can take 1,000 data points from this heart disease person, and similarly 1,000 data points from this does not have an heart disease person, this column, this data, and I can have a data set of 2,000 rows. Okay, and now you can see this is my balanced data set. It is not a good practice. I'm again saying that it is not a good practice to balance out the data set each and every time. It is not a good practice to balance out the data set each and every time, because it sometimes leads to biasing and all. But I am showing you this because like it is a part of pre-processing technique. I hope this much is clear now. I hope this much is clear, right? If there is any kind of doubt, please ask in the chat, else write clear in the chat. Yes. Sir, how to determine whether the data set is balanced or not? So I can simply write, we have y over here as my output cell, right? I can simply write y dot value underscore counts. Maybe the function is something like that only. Okay, numpy and the array object has no attribute value underscore count. The function is something like that only. Okay, leave this. What I can do. Okay, this is not happening because actually this is not the part of our data frame. Okay, this I got the error because this y over here is not the part of our data frame. Okay, so if you just want to check whether the data set is balanced or not in a classification problem, what you can do, you just have to run this cell on like the data set, and you have to mention the column name. Okay, you have to just mention the data set you are using, and you have to mention the column name. Okay, like any of the column name that you have to see. Right now I don't have any categorical column or any output column in my data set. I have the output column separately, but you just have to mention the column name, and then you have to write this value underscore counts. You have to run this, and you will get to know that whether your data set is balanced or not. I am unable to show you because I don't know why the file is not uploading. I don't know why it's not uploading. So you guys, what you guys can do, you can try it by yourself as well, and you will have a good practice of this as well. I hope everything is clear now. If everything is clear, write clear in the chat quickly, guys. If everything is clear, write clear in the chat quickly, guys. Great. So this is it for today's session, guys. You can just simply go and fill out today's attendance form. It is there in the chat. Just quickly go and fill out the attendance form. And if you have any kind of doubt, you can ask me through the chat. The attendance form is there in the chat, so quickly go and fill out the attendance form, guys. And if you have any kind of doubt, you can ask me in the chat. I've already explained standard scalar and label encoder. If you still have any kind of doubt, you can just go through this video lecture again. This will be uploaded on the DevTown YouTube channel. Imbalanced dataset implementation, I'm not able to upload the dataset right now. I don't know why. So okay, I will just show you a previous code for imbalanced dataset. Okay, just give me a second. I will show you a previous code for imbalanced dataset implementation. Hmm. Okay. Mm-hmm. Maybe it's somewhere over here only. Yes, handling imbalanced datasets. So as you can see, I have taken some heart disease.csv dataset over here. So this is my dataset. Okay. Now this with the help of this dot value counts. This with the help of this dot value counts, what I am seeing, I have only 27,000 values for yes. Okay. And I have some 292,000 values for no. So as you can see, I have a lot more values for no as compared to yes. I have only 27,000 values for yes, and I have only 2 lakh, and I have 2,92,000 values for no. So this is what we call an imbalanced data set, and I don't know why it's not balanced. So this is a simple example of how can you check the total number of like values in each category. Okay, I hope this is clear. Now, how to balance this data? What you can do, you can just simply take 27 or 30,000 values from this no part. Okay, the data set, I don't have the data set right now because this is an old, what we call it. Sorry, this is an old code of mine, so I don't have the data set right now, and I don't know why the data set is not uploading. So you guys can also try to balance this dataset by simply you can take only 30,000 values for no, and you already have 30,000, approximately 30,000 values for yes. So that is how you can balance this. But balancing the dataset is not a very good practice in every case. Okay, so because it is a part of preprocessing, that's why I'm teaching it to you. But it is not a good practice to balance out the dataset each and every time. I hope this is clear. The attendance link is there in the chat, so please guys quickly fill out the attendance form because it is very much important for the certificate parts. Yes, if you have a knowledge of your data set, then it's a very great thing before coding, because then you can perform some kind of analysis and all. Okay, so if you have some kind of data set, if you have some kind of knowledge of about what kind of data set you are using, it's a very good thing. If you have used label encoder, you have to store the value in some, we can say, somewhere as well. Like, just give me a second. Hmm. Okay, I can show you a previous code for label encoder as well. Label encoder. Yes, label encoding. So as you can see, I have used the iris dataset only. I have imported both the standard scaler and label encoder. I have read the dataset from with the help of this dot read CSV. Okay. Then I have checked for any null values in the dataset. I have told you this step in the last lecture. With the help of dot is null dot sum, I can check for any null values. Then I have applied label encoder. As you can see, before label encoder, this fourth column have the values like iris setosa, iris virginica, and all. Okay, but after applying label encoder, like I have used label is equal to encoder dot fit underscore transform, and I have applied label encoder on the fourth column. Okay. So after applying this label encoder, you can see my fourth column is now converted into zeros, ones, and twos. Okay. So as you can see, Iris setosa is assigned the value 0, Iris virginica is assigned the value 2, and somewhere in between we have Iris versicolor, which is assigned the value 1. Okay. As you can see, Iris setosa, Iris versicolor, and Iris virginica. I hope this much is clear now. How can we apply label encoder? Guys, the attendance link is there in the chat, so please quickly fill out the attendance form because it is very much important for certificates part. I've already covered a bootcamp on how to make chatbots. Like in that bootcamp, the project was Telegram chatbot. So if you are interested in that, so you can just go to DevTown channel and watch my previous bootcamps. I have done the bootcamp on generative and prompt engineering, in which I have taught how to make Telegram bots. Okay, so you can simply go and watch that video if you are interested. So in today's session, we have learned how can we deal with the pre-processing. Well, like what are the different pre-processing steps in machine learning. We have mainly four steps, majorly four steps. The first one is handling the null values. The second one is data standardization. The third one is label encoding, and the fourth one is handling imbalanced data set. I hope this much is clear now. Yes, you can use dot map in a like in some specific use case only you can use dot map. So I want you to study more on this dot map function if you want to use this. Hyperparameter tuning is like we are going to cover that topic in, suppose in, let's say I am going to cover that topic in fourth lecture maybe. Okay, so yes, we are going to cover that hyperparameter tuning part. Value count function will show you the values in each and every category. Maybe I have used the value count over here. um, um Yes, the value count function shows you the number of rows in each and every category with respect to that particular column. So I have used the fourth column over here, right? So I can see all the values, all the rows, like I have 50 rows in Iris setosa, I have 50 rows in Iris versicolor, and I have 50 rows in Iris virginica. So this notes that we have a proper balanced data set in this case. For attendance, I have shared the attendance link in the chat and I am again sharing it. So please fill out the attendance link for today. Please fill out the attendance link for today. The project and all is I'm going to explain the project and everything in the fifth class, that is on Sunday, I guess. Okay. So everything related to the project will be discussed in the last lecture, that is fifth day of this bootcamp. So machine learning is the very first step towards the artificial intelligence field. So all of these basics are very important, and whenever, like, if you guys are really interested, you will also if you want to like pursue in this field, so these are the very basic question and concepts that the interviewer will ask. Okay, the notes will be provided in the community description only. Okay, so this is it for today, guys. If you have already filled the attendance form, you can leave the meet, you can leave. Okay, else please quickly fill out today's attendance form. It is there in the chat. Regarding yesterday's attendance link, if you have missed the yesterday's attendance, don't worry. Just fill out the attendance form for rest of the 4 days. I hope this much is clear. That's it for today, guys. Thanks a lot for joining. Thanks a lot for joining, guys. Let's meet tomorrow on the same time, that is 7 o'clock.